notebooks here. Okay. This is what we're going to be talking about. I don't know. See if you can see them. Maybe you can't see them too well like that, but 100% of these pages is all math and calculation. There's no words on anything.
Oh, whoa. Okay.
Okay. These are like advanced, like, calculus, stuff like that.
Mm-hmm.
And there's about 400 pages.
Whoa.
And nobody in the family knew these existed until I figured it out.
Damn,
So
bro. Okay.
it's gonna it's gonna be a fun one.
Hell yeah.
Yeah. Hell yeah.
Mm. Sorry, I
What are you
haven't eaten
munching on?
anything.
Oh, you're good.
Waffles. Sugar waffles. I
Probably
haven't eaten anything yet.
pretty pretty late for you right now.
It's about 7 o'clock in the evening, but I
Oh, easy peasy.
yeah, but I worked the night shifts the last 3 days.
Mm,
Um,
mm. So it's morning
so
time.
my
Good morning.
no, it's actually evening now, but it it feels like morning
Yeah.
because I've only been up for a few hours.
MOU morning. Morning time.
No, no. Thankfully, I've had plenty of that lately, especially with
Mm,
the wifer side of the family. A lot of yeah, a lot of people falling away all of a sudden.
yes. Yeah. I've had quite a bit recently as well. Mm,
Well, luckily, none in the family
mm,
here. Well, not recently. Luckily, let's
yeah.
fucking keep it that way. I've had quite enough of family members that I hold dear falling away.
Mm. So I do have a lot of graphics that I've generated, and
Okay.
I've made like TikTok posts and Instagram posts, and my TikTok posts about this got hundreds of thousands of views, and and uh, I didn't even like make it clear what I was even talking about. So
Hmm.
so I really wanted to do a podcast because I want to like be able to verbalize what the hell this is all about because his notebooks are 100% math.
Oh
And
shit,
so
man.
to and so to understand what he was working on and explain it is like, you know. So
Yeah.
um yeah,
What
where
is your
anyway.
TikTok? Because I'm not even following you.
Oh, I just have one because I have a restaurant. So I just have my restaurant one, but
Oh.
on TikTok I just post everything. But yeah, I have like other videos like regarding the restaurant with like millions of views on TikTok, um but it's not really anything. It's just me being funny, like silly
Okay.
nonsense content. I'm trying to do this one right. So I had my grand opening on spring solstice on March 20th.
Oh hell yeah. Hell
So
yeah.
I'm trying to be in line with the stars and the universe, you know?
Yeah. Good shit. I mean, new like
Yeah.
literally new year, new beginnings. So
Yeah, that and this my granddad stuff like sent me down this rabbit hole. Like I only discovered like what's in these notebooks um like 6 months ago. So right when I was like kind of like resetting and rebranding everything, and then I could not stop thinking about this and I was like obsessed with it. And it's like I can't do all of these things at once. Like I was like one piece of content I made, I was like making a smoothie and pouring it, and I'm like, when you discover your granddad rewrote all of atomic physics and solved all of like the singularities in mathematics, but you're just over here and have to keep making smoothies.
hey. Oh yeah,
Yeah.
man. Like one's a genius, the other makes smoothies.
Yeah, exactly. I know it's definitely skipped a couple generations here. Yeah. Or they just don't make
Yeah,
humans like they used to anymore, but we're trying, you know.
I mean, yeah, that's what we're trying to do, right? Trying to get back to that level.
Yeah, make better humans. Yeah,
Yeah, and hey, it's fun making them, so
it is. Yeah, there you go.
I'm
On the
not
bright
complaining.
side.
But I'll like not clip that because that's a little.
Oh, my bad. Excuse me. I didn't know we were recording already.
No, no,
I
no.
didn't know we
That's
were
that's
recording.
that's
So
no, that's fine. I
I'm
have
gonna.
it on record automatically. Like so, whenever someone joins the studio, it
Okay.
just
Well,
it starts recording
I would
automatically.
say got it.
I mean, like, everything before is going on the Patreon, so it's behind a paywall. The Warrior Aristocrat tier, I have like full shows just uncut, so just
Got it.
audio cleaned up a bit, like
Dang.
no
Well,
intro, no
you.
outro, everything just raw and uncut.
All right. Well, all right. Sounds good. Yeah,
Or
I would like my personal life to be separate from, well, this is kind of personal, I guess, at this point, but I want to make it more known.
I'll
Ready?
do the proper intro.
All
So
right.
let's like for YouTube and all the other platforms, like from the intro is when we actually get started.
Okay. Let's go.
Welcome back, everyone. Welcome back to the Greyhorn Pagans podcast. It is good to be back. Thank you all for watching. Thank you all for listening. If you have been a subscriber for a long time, or just a regular viewer, you might recognize the guy on the other end of the screen. Dustin, we have done at least 3 Box Saga shows together,
Yeah.
which were well received. I don't know the views from the top of my head, but they were well received. So for a obscure topic like Box Saga, hey, that's pretty good. Let's see actually what did they. So the round table, that
Well,
was the Box Saga round
we're
table
gonna
was a
go
good one.
way more. I wasn't part of that.
You weren't? Oh shit, man.
No,
Because I had
no,
I
that
had
was.
Paranoid American. I had Andy from Deep Share, of course. Like I had a whole bunch of Buck people. So for those who haven't seen the Buck stuff, yet and don't know you for some reason, then they haven't been paying attention. But introduce yourself. Who are you? What do you do? What's your secrets?
Um, so I'm Dustin. I'm just a dude. But uh I came across something far more obscure than the box saga, if that's possible. Far more obscure. And I wanted to share it with you. So it's a new atomic theory that I found in my bedside drawer. And it's not very often you come across a new atomic
Huh.
theory that rewrites everything standard physics um, accepts today. And yeah, and it was back in the 80s when these notebooks were made. And so I want to introduce you to my granddad, Phil. My granddad, Phil, was a mechanical engineer, and um, and he died when I was 1.5 years old. So I never really knew him. And he actually died. His last entry in these notebooks is 2 days before he got sent to the hospital and then died in the hospital.
Oh
So he
wow.
these are essentially um it's not unfinished, but it is kind of unfinished, which we'll get into.
Yeah.
But basically, a few years ago, maybe about 4 or 5 years ago, my dad mentioned that he has these old math notebooks of my granddad's. And
Hmm.
ignorantly, I was like, well, I was pretty good in math in high school and took some calculus classes in college. Maybe I could take a look at them and figure them out. And I took one look at them and I no clue what I was looking at. I skimmed through it, maybe spent about 5 minutes, and then closed them, put them in my note drawer for about the last 4 or 5 years, and they've just been sitting there. And then this year, when I had to do all my taxes, which is very complicated here for some reason. But it required me to scan some documents with my phone, and I was already working on trying to get my grandma from my mom's side. She has an old computer and she really wrote journals and wrote a lot, and she was a librarian in her past life,
Okay.
and uh, and so I was trying to like compile everything digitally so I can um, kind of take a look at it and read through my grandma's works and stuff like that. Um, and uh, and so I found this AI. Have you ever heard of Notebook LM?
It no, I can't say I have.
Okay, so it's not like ChatGPT or like Claude or any of these. It's kind of like it's an AI that's trained only on the sources you put into it. So like in my real life, I have a small business, and so I use a lot of my spreadsheets and things like that, and I'll put it into Notebook LM, and it'll help me analyze all my data, and I can just ask it questions like, hey, what were my sales on, you know, Wednesdays compared to Mondays or whatever. I can ask it anything, and it'll about the information that I've already put into it, and then it'll feedback, give me the answers. So it's like having someone who knows all my notebooks. It's a notebook, right? If I asked it what the weather's like in California today, it would not tell me. It wouldn't know. It's like there's nothing in the sources that'll tell me what the weather's like in California,
Hmm.
right? Whereas in ChatGPT, it's just like assumes it knows everything, or it'll just give you an answer even if it doesn't really know the answer or whatever. All the problems with people think of AIs are mostly
Yeah.
with the chat AIs versus this kind of AI.
Yeah,
And so
the
this
the
one,
the
mhm,
large language models. Yeah.
right. Yeah, so this is a language model, but it's not a large language model. It's just
No,
the language of the sources. Yeah.
it sounds more like a kind of like an AI assistant, AI personal assistant, if you will. Um
Right.
I
Like if you were
can
to ask, yeah, if you were to ask about, what are pagans like in Chat GPT, it'll give you an answer that you definitely won't agree with, right? And but if you only put in your own sources of your understanding or your sources or your information or your notes and notebooks, it'll just tell you exactly what's in there. So it's like also great for like Bach Saga stuff. I could just take, actual like Eeyore Bach recordings, put it in a notebook LM, and I'd be like, what does Eeyore say about this? And it'll just tell me, right? Like it
Oh,
doesn't
okay.
bring in like all the other nonsense. So there's a lot of uses for it, right? And so I was thinking
Yeah.
about using this for my grandma's computer, and things like that, and so I can kind of whatever go through her stuff. But then when I was doing my taxes this year, I was like, well, what if I were to scan all 400 pages of these notebooks with my phone and then just drop them in a notebook LM and see what it says? And what I did that. And so I spent about 20 minutes just scanning, just flipping the pages and with my phone, and it scanned all these pages. And then
Mm-hmm.
within about 5 minutes, I was my mind's completely blown. Okay. So what it was telling me that my granddad was working on um completely blew my mind. And so I started with just like the first like maybe half of one of the notebooks in the notebook LM
Mm-hmm.
AI. And it was basically said that he was creating his own atomic theory from scratch, his own equations, his own um, everything. And what I came to find out after I finished scanning all the notebooks, that these two notebooks are actually, so there's two notebooks here. These are the first entry is December 1985, and the last entry is December 1987. So this is 1 year. Each notebook is 1 year's worth of notes, and every page is dated, the day, month, and year that he was working on it. And what I came to find out is actually one big project.
Oh, wow.
And this one big project, so my granddad was a Texas oil man. He was a mechanical engineer, and so he was responsible for engineering new uh, oil pumps and drilling all around the world. So they would fly him out, and he would basically engineer big projects for oil. So he'd go to the Middle East and Europe and all around the world to kind of do the and so he's engineered it. And so what's in these notebooks is that he engineered his own atomic model. And so how do I start
I mean,
kind of like opening up
the
this
atomic,
fractal?
yeah, but the atomic theory, the atomic model. I mean, um, I have a quick summary pulled up, of course,
Sure.
for those who may not be familiar. I mean, it's not something that you talk about every day. It's like atomic theory is not really like
No.
water cooler talk. It's like, on Mondays, hey, so, what do you do on the weekends? Oh, designed a new atomic theory because fuck it.
And it's
Uh,
changed since he wrote these notebooks. So the
oh,
standard theory, they call it the standard theory, is the one they use today, and then the or modern or standard, but the previous one was Bohr's model, which is like the little solar
yeah.
system. You have the nucleus and then the electron spinning around it. And the standard physics does not use that one anymore. But go ahead. What's the summary?
No, it's, I mean, modern atomic theory was formalized in 1808, and it is the scientific framework stating that matter is composed of discrete units called atoms. I mean, we all basically know that. Um, Concept, of course, originated in ancient Greece, because where else? Um, but it transitioned into a rigorous scientific theory in the early 19th century through the work of John Dalton. I did see, Niels Bohr, and others later integrated quantum mechanics to describe electron behavior. So, yeah, it's really the modern atomic theory was formalized by John Dalton and then expanded upon or refined by, well, Niels Bohr and others.
So
But that's been basically, um, it's been a formalized theory since 1808, and Niels Bohr and others, that was around 1911. So it's a good 100 plus years, almost. Well, I want to say like almost 140, 150 years of the modern atomic theory, if you will.
right. And so I just want to point out that the word theory is them going, yeah, this, but maybe not. That's what the word theory means is,
Yeah,
but maybe not, right?
it's like
And the
it's most
reason,
likely this, but we don't have a way of like proving it. It's something
right,
that we
mathematically,
speculate. Yeah,
hmm
exactly.
so that they
The
don't have
math
a
says
mathematical,
it's this. Yeah.
yeah. So let me go in a little more detail too of what kind of standard physics says today. So so there's a few concepts that and experiments they've ran to show current standard atomic physics, basically, right? So basically, they say that the physics of us here in reality is you throw a ball with the same force, and that ball has the right same mass, and blah blah blah. It's going to land. Everything's going to happen exactly how it's going to be mathematically happen. There's physics to show. When you take a ball at the end of a string, there's forces that make that ball want to fly away, but it's attached to the string, so the string's pulling it back like a fan, and it's also not falling straight down because what blah blah blah, centripetal force, all that kind of stuff. Once you get down to the atomic scale, all that's out the window. We have new math to explain the atomic world. And so back in my granddad's day, it was the Bohr model, where a little solar system and you have orbiting electrons. And that electron is in some location around its orbit, kind of like a solar system. And then you have the proton just chilling as the nucleus. Um, and then you also have, so in standard physics today, they threw out that model and now they call atoms little clouds of probability. That a particle could be in two places at once. These are Schrodinger's concept. Schrodinger's cat is the cat. There's a cat inside of a box, and that cat is both dead and alive. But the act of opening the box and observing the cat determines that the cat is dead or alive.
Well, it's a little
So
more
it's one of the two.
nuanced, but yeah, there's like a poison within the box, like poison food or poison canister of some sort. Um, and you won't know if the cat, you know, has been poisoned or is died or not. So yeah, the theory
So
basically
yeah, well,
states that the cat is both dead or alive. As long as you don't open the box, it is in two states at the same time. It
yes.
whether it is one or the other really defines on proving it. So, like opening the box and looking at the cat, seeing if it is dead or alive. But yeah, Schrodinger's cat,
Yes,
very
but at the
popular
same yeah, but
experiment.
at the same time, they'll also say every time you open that box, the result is only it's only a probability that that cat is dead or alive. That is not determined until the act of observing it. So so
Yeah.
they still do this with the electrons are in two places at once. I'm waving to you with both hands, but because you're watching me wave to you,
Hmm.
I'm only waving to you with this hand. But actually, I am waving to you with both hands, but because you're observing me, it
Hmm.
influences, right? So you look
Yeah,
away and you
and
look back, now it's this hand, that kind of thing.
that kind
So
of also goes
this
into the double slit experiment where the
yes,
particles like behave in a way that you expect them to behave because you're observing them. If they're not observed, they are in a state of chaos. if you will. But as soon as you start observing them, they behave like you expect them to behave.
I I believe the original intent of that experiment too was different than what they currently accept as what it's explaining.
I mean,
So
probably
originally
like
the double
atomic.
split was
Sorry, go ahead.
to originally it was to determine whether it was a particle or a wave that we're observing or that's being shot through the first slit. So if it's a particle, it should go straight through one slit, straight through the other slit, and hit the one atom of gold on the other side. And if it's a particle, it'll go straight through. But if it's a wave, the wave will go through one and then go through the other, and then by the time it hits a wall, it can be anywhere up above or below the second slit because it's a wave. So it might hit the wall up
Yeah,
here, might hit it down here, it might hit it in middle, and so that they observed it hitting in different spots. So they're like, oh, it must be a wave function, and now, like you said, they also interpret it a new way where it's not about waves and particles, but it's about probability. And so this
yeah,
whole
and
issue with probability is completely solved with my granddad's work. Um, and the other problem with the probability is that it creates singularities. And a singularity, a mathematical singularity, which a black hole is an example of a singularity, where the distance, when they're calculating distance, as that distance approaches zero, the forces to hold those things together approach infinity. So, and
yeah,
that's when the math starts to break down because the numbers get too crazy in both directions as you approach zero and approach infinity at the same time with distance and force. Um, and then we also have the butterfly effect, which is actually
yeah,
originally out of mathematics. So the butterfly effect, you step on a butterfly in the Amazon rainforest, and 1,000 years later, you get tornadoes in Europe that wipes out whole cities or something like that, right?
yeah. No, it's
So
a butterfly, like a butterfly flaps its wings, and that creates a little bit of air friction, wind friction, which goes into a storm, goes into hurricane and whatever. It's basically a small thing, big impact, but like on the other freaking side of the world, there are many such theories. Another one that I like and I've seen a lot about recently, which I'm still trying to grasp, is that and this is a strange one, that the future can influence the past because like time doesn't really exist as we know it. So future events can influence the
I'm
past. So
I'm so excited.
things that haven't happened yet can influence things that have already happened. How that works, smarter people than me are, busy working on that. So
So
I have no fucking clue.
so
I know it's something that's being worked on, and I know it's fucking freaky.
so speaking of time, is one of the equations of my granddad's is he rethunk time. So we'll get into that in a sec. So, and then the other one is the three body problem. So this one's going to be important context to know. The three body problem is also kind of related to the butterfly effect, where there is no unified equation to calculate the trajectory or the location or speed of the third body when, for example, like if you have a double star system and then one orbiting planet, how that planet is influenced by these two different two bodies, how the third body is influenced by that. They don't have a unified calculation to calculate that with changes of mass. So you change the mass of one of those bodies a little bit,
Hmm.
they have no clue what because everything's calculated with probabilistic atomic theory. It throws all these things off and creates these singularities, and they'll never be able to prove anything because their math is wrong from the smallest level.
Yeah,
um, and the helium atom is one particular atom that represents the three body problem. So standard modern physics has not solved the helium atom, which is number two on the periodic table as a three body. It's a three body problem at the atomic scale. And so that was what my granddad had laid out the introduction to solving in his notebooks and then died. So he solved these notebooks are 400 pages of his proof of the hydrogen atom, the first atom on the periodic table, and then he was going to tackle the helium atom because he saw it representing the the final like solution to all of these things of his proof of concept, because he basically proved all of his equations with the hydrogen atom, and
Mm-hmm.
then using the same equations was solving for the helium atom. And I've been playing around with AIs to create simulations and write computer programs to run the simulation of the helium atom, and it showed that it was correct after running a few simulations and making a
Oh,
few
wow.
changes. So let me get into it. So
Yes, please.
um, okay, so originally I thought these notebooks, like there must be more of these notebooks. Like you don't just like math math it up every single day. He would just go in his garage and smoke cigarettes, and no one knew what he was doing in there. Like I asked my dad and my aunts and stuff like that, like what he was up to, and they're like he would just go in his garage and smoke cigarettes. And when my grandma passed away years ago, that when we were going through it, we my cousins and I were most fascinated with his old school Playboy collection. So no one really noticed these notebooks. He had a really prolific 70s Playboy collection. But
Old
I don't
school.
know what else he was doing in that garage. No, anyway, but
I don't want to
and
know.
but yeah, we're not talking about Box Saga. No, I'm just kidding. So
Poles and holes.
so I'm gonna call this his atomic theory the clockwork atom theory. And he basically viewed atoms as cubes, and that instead of electrons orbiting along some kind of two-dimensional axis, they orbited along the faces of a cubic structure. And the protons themselves also had an orbit, but these orbits of the particles within the atom are connected. So think of like the gears in a clock. When one gear turns, so does the other ones. And some gears are bigger and smaller, and so they rotate at different speeds but are perfectly synchronized. And so you can apply that to every atom along the periodic table using six sides of the cube of a cube, and that the particles move along time intervals. So this is like maybe the biggest insight that I think was most fascinating and is most likely to be true, which is instead of time being a continuous flow, um, where like you get it's there's actually a frame rate to the universe, that they're ticks, they're time intervals rather than a continuous flow. And there's a calculatable time interval at the atomic level. So an infinitely small, not infinitely small amount of time, like a flow, a vector would be, but a tick. And I just thought that was interesting because we think of time as a tick, seconds, minutes, hours, years, weeks, months,
Yeah,
blah,
it's
blah,
just
blah.
the
These
tick
are, we
gets
think of them as
longer
time
in
intervals.
between. Yeah.
And he's just saying that's actually also true even at the smallest time interval. And that the speed of light, that these particles jump along these time intervals and turn like a 3D clock. And using this time interval, he was able to attach it to known constants. So the Bohr model of like a solar system was thrown out, but there is something called the Bohr radius, which is a basically a hard fact of the distance of distances in the atomic model. The distance an electron is from a proton, something like that. So it'd be like the Bohr radius is what they call it. Um, and he would attach this time interval to the Bohr radius to turn it into a force vector. And
I mean, I'm not that
no
scientifically
worries.
educated,
No, I
so
know this is like really. I know. I'm like basically learning all. Not. I'm. Yeah. I'm like going into what they currently say to compare his model,
yeah.
and it's just I find there's so many errors and known problems that are unsolved in standard theory, whereas he's fully worked this out and solved and balanced. So one of his equations is like he actually uses zero as for stability. So when all of the forces within the atomic system, so you
Hmm.
have the centrifugal forces that pull particles away from the
Yeah.
spin, and then you have the forces holding it in, and then there's um, and then he also made a new force where each particle is also spinning. So just like the planet, right?
Yeah, I
Uh,
was gonna say, like, if we're going by, like, the age old principle of, as above so below, as within so without, then it would make sense that if our or how we perceive the atomic theory, how we perceive their movements, if it revolves around the nucleus, like we're taught that the planets revolve around the stars, the planets themselves turn as well. So it would only make sense if on the atomic level um, that would happen as well, because as I said, as above so below, so as within so without. It's easy to to throw that sentence out there and sound
yeah,
cool, occult, and
and,
smart, but
and just a
it's
little
true, and it's
thing
been
is
proven numerous times. So it's awesome to hear that you're like, and I mean, even just that, it's so it's so simple, and it makes so much sense. Like, of course, on the atomic level, it would work the exact same. I mean, we're already, you know, theorizing, trying to prove that it works the same, and science and the occult is sort of, kind of slowly catching up to each other. Um, occult sciences prove mainstream sciences, and mainstream sciences has a tendency to prove occult sciences. So, but I haven't heard before about, like, even on the atomic level, that the particles, also revolve around their own axis. Well, it would absolutely make sense.
yeah, and so he well also they don't use that the solar system model. They call atoms now clouds of probability. That's literally the term they use. Clouds of
God,
probability. That's what an atom
I
is
oh no,
in 2026.
I hate that.
So and this is the whole reason because their math is so broken and they're using like physics that doesn't exist out here where my granddad was a mechanical engineer, right? And so he's using the same physics of that ball spinning over your head on a string
Hmm.
at the atomic level. He's not using new physics. He's using mechanical engine physics, like in the real world, to and applying it at the atomic scale, and created or built in these notebooks. So keep in mind, this is in the 80s. Okay, we don't have phones, calculator. Like they just came out with the first scientific calculator that is a programmable calculator in like 1979, and they were $8,000.
Holy shit.
So what I think is what happened here is my granddad had this idea in his head for decades, but lacked the techno they the technology didn't exist for him to actually run these calculations. And so these notebooks, um, I don't know if I can find the page just like right away, but basically he would use known like the Bohr radius and
Yeah.
gosh, what's the other one? There's another one that's called Planck's constant,
Oh yeah,
Planck.
yeah, 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 yeah.
Planck's constant. He
Yeah.
does use that. He uses Planck's constant because it is a constant, but they call it a constant. A constant for what? Right? They don't, he turned it actually into a force. And so it's actually something that his calculations reach Planck's constant and Bohr's radius without including them in the first place to
Oh.
prove his model. So, um, so a lot of his, and so once they invented the first or second or third generation of a programmable scientific calculator, um, my dad still has my granddad's old calculator, somewhere,
Mm.
but, you basically, um, you have to run like sequences, programmable sequences to run these equations, right? Because it's not just simple like add, subtract, or whatever. And so what he would do in these notebooks is or multiply, divide, square, square
Sure.
root, all
No,
that kind
yeah,
of stuff.
this is
Um
the I mean, but this is all
he's
what we now, put under the number of quantum mechanics.
Yes. Yeah, exactly. And so you're working with numbers that are like, you know, 1.726473 to the negative 10th, kind of
I mean,
stuff. And so,
I can pull it up. I have something pulled up on screen. It is Planck's constant, and then like also for the audience, like you can see what we're
oh,
working
I
with.
found
Like
it.
this is not your regular. This is not your regular, math class. It's now defined as exactly 6.626070015 times 10 to the power of 34 joule seconds.
Yes. So,
So that,
so,
yeah,
so
no
for
idea
him to be able
what
to,
that is or what that says, but sure.
yeah. So for him to do these calculations, he had to program every step of the calculation into the calculator. But the calculator of this time had like little cards that you program like the equations into onto
Yeah.
these little cards and you put them in the calculator and then it runs that equation. And it only had the memory, the RAM or memory to hold like three programs. Um Here's one program that he ran which 288 steps.
Phew.
So
Okay.
what
I
he
mean,
would do is he would go into his notebook. Let me do it like this. So he would go into his notebook and he has program force. And he would go into his notebook and he would start scaling. He would write out all the steps of the program
oh
along
my
these.
god.
And
Yeah.
so he can keep track. So he would have to keep track because first he would run like three steps of the process. He would have to write down the number of um the that and then re-input it and continue all the way through. And this one keeps going, and so this is called program force. So he's calculating the frequencies and energies that are being coming off of the atom maintaining
Mm.
stability. So create the light frequencies, the sound frequencies, all whatever frequencies come off of it. Like I like you, I'm not like super versed in that, but there is multiple forces he was calculating with his own equation. So the calculator doesn't know these equations, right? So he has to program these equations in to find, the solutions. And he would run these programs over and over and over and over and over and over and over every single day for 2 years. And so what he was doing is basically his atom is a cube. I feel like I should have a here we go. So his atom's like a cube, right? And so
Yeah.
you have the electrons orbiting along the face of a cube, and then along time intervals. So every second, universal second or minimum time interval is what he basically called them. Oh, and keep in mind, everything I'm describing, he didn't write in words. There's no words. There's not one page with a paragraph going, this is what I'm trying to do. It's all math, all numbers. There's no words.
Oh.
Every once in a while, he'll take a whole page and he'll put an X through it and go, nope, just no, no. And then, uh, um, and then the AI found the page where he solved it. But anyway, so the first page of the notebook, or the first few pages, they're kind of laying out the general idea. So it's just like little diagrams of, basically the inside of a cube and just like the location of where everything would be. There's just like a simple diagram kind of stuff over several pages, and there are trajectories and angles and angular forces and whatever, the location of the electron. So
Mhm.
what he does is he maps the full cycle of the helium atom and all the location of all and force trajectories or force equations along. He mapped them along each time interval. So time interval number one, everything's located here and here. Interval number two, located here and here, all the way down. So these notebooks are basically, if you consider time the fourth dimension, this is a four-dimensional blueprint for the hydrogen atom over the course of 2 years of 300 pages.
Wow. Okay.
And at the very end of this, AI found this part where he circled this number and go, "This is it," and that was his big hoorah of solving it. Fucking crazy, dude.
Wow.
Yeah, and yeah,
That's
it's a lot.
yeah, and it's all, and he did that all just in the 80s when, as you mentioned, we didn't really have those, well, technologies yet, or they weren't as advanced yet.
Yeah, I always wondered if he had a computer, if he would have done this in 10 minutes or still would have taken 2 years. I think about that all the time. Like, dang, like his whole life's work, he could have been, like, maybe just figured out right away with like a little computer program, but they didn't exist.
Poof.
Yeah. So
So,
he,
but I love that
yeah, go ahead.
he took existing theories, existing principles, because that's what you'll find with a lot of these, well, like armchair scientists, if you will, or people who just got onto some crazy idea. They create like a whole new system, and then like go through so much effort to tell everybody, like, no, like my system is legit as well. But he took existing principles and proved them, like, again, but using different maths, different calculations. That's
He just, yeah, he had, I think there's a total of 3 or 4 total equations that are uniquely his own. And AI kept saying this is a start from scratch method. And so he used, like you said, the existing principles, and he has sources too. Like he's like, I've taken the mechanical engineering principles from this book, and I'm using benchmark data points to reach to show that it's correct. So if I do all these
wow.
calculations and it's not Bohr's radius, this isn't the right um, integer or whatever I'm using. It
Yeah.
Once it reaches that, he's like, got it, next. And he used the benchmark data points of like known he also, he ripped a few pages out of other books of just showing like the mass of certain particles and different things that are the benchmark data that's known, that's not like it's something you can calculatable already,
Hmm.
like of the hydrogen atom, and reach those numbers independent of them, like what you're saying. Yeah, you said it better, but
Yeah, no,
yeah.
it's fine. So do you have any idea of? I mean, it's a very well simple question, I guess, but very loaded question. Do you have any idea of why, or is it just something? Is it just something that like came into his mind from fucking wherever, and he was like, I gotta do this.
I think he just okay. He didn't use many words, but he does have something in one of the very first pages. Um, and it was a quote from someone else that was basically like the it was along the lines of, we can no longer entertain the ideas of quantum mechanics. Like it's like they're obviously wrong. And that was like his main thing, is like, this is wrong. The Bohr model is wrong. The atomic models we're using right now are wrong. And um he already has the math and real world experience of building something that works. Like I
Yeah,
said, he was in the oil industry, and so he was involved with all the mechanical engineering of, these are like fluid dynamics and pumping systems and drilling and pressure, and like all this stuff requires intense calculations to build these projects out.
yeah.
Um and so, like I said, I feel like he had this in his head. And when I started like figuring this stuff out, and I'm like, my dad was like the only one who's like kind of interested in hearing more every day, a little bit. Whereas my aunts are like, they're like really brilliant artists, but this is like way over pretty much
Oh
everyone's
yeah,
head. Like this does, like, what do I even do with this? I don't know quite yet, but what its implications are also pretty fascinating, which is, um, I think there's a debate of free will to be
yeah.
had with his model, because his model is basically saying that if you take his model and apply it to the double slit experiment, it's because if you started measuring these particles along these time intervals when you first launch them through the slits, then you can determine exactly where they'll be, and they will be in different places because they're in different locations when along different time intervals. But no one, but because view time as continuous, there's no way to determine. So everything becomes probability. But just including the time interval makes everything, takes it from probabilistic to deterministic. And I was thinking about, same thing with uh, singularities of, like, as distances approach zero, forces become infinitely strong.
Yeah.
He also solves singularities. Like black holes can be explained better, and you were talking about, you're fascinated that we could possibly influence the past. Well, I don't know, but he's doing something with time here that is, I don't know. I feel like you can't have free will if everything's probabilistic, because everything is a possibility in the future. Um, just as standard procedure. Whereas if we have free will, which I believe we do, that everything else, if I kick a rock and I will break my toes every time. But or you step on a butterfly or whatever, the butterfly flaps its wing or whatever,
Yeah.
it is a calculatable thing, right? And they invent quantum computers, is the whole idea behind this probabilistic universe that we're is still called a theory, because we need to be able to calculate all the possible outcomes and sequences. Just like chess moves, if you move your pawn here or this pawn or this pawn, it opens up this whole fractal of other things.
Yeah, and
Whereas
with
he's
every
saying we
move, the
know
game
exact.
changes, the board changes, the whole game changes. Yeah.
Yeah, but his model, especially once you start going into more complex atoms, or like uh uh you can determine where these particles will be. So you can determine the frequencies and effects at the smallest level, and that can completely rewrite everything. Even
So,
yeah.
but how does that make the case for free will? Because free will and determinism.
I love this.
In my mind, I may be wrong. To everyone watching and listening, if I am, please do let me know. But I feel
You
like
are
that free
no.
will and determinism is diametrically opposed to each other. Like determinism is
Yes.
there is an end goal, and free will is there are I don't know how many fucking end goals, and it really all depends on what you do at this very moment. Just just like the game of chess that you just mentioned, like move my pawn there, and then these options open up. But if I move it there, these options open up, and it's all a matter of what do I do. But deterministic or determinism, it it's having
So
a set point and working towards that.
yeah, determinism will be more like all of your life experiences leading up to this moment right now is causing the certain little chemical little firings in your brain, and is exactly you're basically just programmed based on chemical reactions and da 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 da. And so your next thoughts, your next move, your next everything is already determined based on
Because
everything
of
else.
yeah,
So,
yeah,
but what I'm saying is that saying there's a probabilistic atom, like in standard physics, is saying that a rock has free will because all the atoms within it are all probabilistic, clouds of probability. So everything is free will, and everything's a possibility. And anything could happen because particles are in two places at once, and everything's just uh, random. Basically, everything's kind of probabilistic. That's kind of, and it's like, how can you have free will if at the atomic level, a rock, or every atom has probability? That is free will, but free will is something to do with our conscious, like our choice. We make choices and we can
yeah,
change our mind and stuff like that. Whereas a rock can't do that. So what I'm saying is that his model makes more sense because we can't say we have free will if everything is probability. I'm saying that if
yeah,
everything, all the matter, you know, physical matter, that obeys by the laws of physics, right? Physics is physical, whereas metaphysical, spiritual, these are different things. These might be something else, right? So I don't think his model changes that. But what I'm saying is we can't have free will. Like free will is very a very religious point of view, also, right? God gave us the choice to, we can choose to do something to sin, right, or whatever,
yeah,
right? As an example, that's their argument. We have free will, and so we have to make good choices to be good people and go to heaven or whatever, right? But I'm saying that can't exist. Like that, you're not comparing it to anything if everything's probabilistic. Whereas in his model, we can actually have free will because of matter and being deterministic. Then we have exclusivity to free will via consciousness. And that's kind of that. It's just fun to think about that idea.
it is. It is a it's that's really something to wrap your brain around. God damn, this is the second podcast this week where I'm just trying to fucking wrap my brain around stuff.
Dude, I've
Um,
been obsessed. Like I would wake up thinking about this. I was going to sleep thinking about this. Like everything else in my life was going But I've taken a few weeks off until this morning, so it's a little more
Yeah.
fresh and fun for me. But there's that, and then there's also I was like, well, what about he did everything for hydrogen atom, and I ran simulations and generated programs to run these simulations using his equations, um, and um, and he solved hydrogen atom under his framework of equations where all the forces within the model balance out to zero. So it creates, and that's considered a stable atom. And when those forces get out of away from zero, where one force is stronger than, and they're not all counterbalancing each other, that's when atoms become unstable. But I was like, well, what about bigger atoms? Right? And so what he started doing was the helium atom, which is the classic representation of the three body problem,
Hmm.
which he also solves using just simple, like, it was like times two of like one of his forces, because now there's two um, whatever, there's two electrons or two protons or something like that, and then their balance on either side of the faces of the cube balance each other out, and he solves the three body problem theoretically, but he died with a complication in a surgery before he can
Oh.
fully work it out, which I picked up and put into a simulator, and um, over a course of several simulations, I found a balanced model for the helium atom using his equations. Um, but an interesting one is carbon, okay? Because the face of a cube has six sides, right?
Yeah.
And a carbon atom has six electrons and six protons. So every face of the cube, and then when you think is like open. And so when you start attaching atoms together to create molecules, you can think of like you're taking a three-dimensional clock where some gears are going this way, some gears are going this way, and all the gears, when one gear moves, they all move in synchronicity. And then you start attaching uh, atoms together to create stable molecules, multiple atoms, then those particles in those atoms will also be synced up. And so everything works like a clockwork machine with multiple gears and forces and holding everything, creating stability. And uh, and I think carbon's fascinating because it seems like it's the most open for possibilities under his model. And then and everything's carbon-based life. I just think that's also a pretty cool like um realization that under his model, the carbon atom will be the most like workable, and you connect the most things to it. It's like the building block that has the most connections to build complexity out of, and which is all of our
I mean,
all life cells are made out of carbon.
yeah, that makes sense. If we are, at least we're told that we are, carbon life forces. I mean, our physical being may be that indeed. Um, so for carbon to be the most malleable, the most workable, the most prevalent, at least for for this dimension, for the indeed the physical dimension, and physics is indeed mostly concerned about the physical. That would make sense. That would make a whole lot of sense. So to do all kinds of calculations and do all kinds of work with that, yeah, I can absolutely imagine. I mean, I'm nowhere near smart enough to do that. I suck at math, always have. Um, Luckily, with podcasting and working in security, you don't really need math. So hey, great.
Right.
Um, but it makes a whole lot of sense, actually. This is all
Yeah.
incredibly fascinating, and yeah, man.
Yeah. And because even a fat molecule, I was just out of curiosity, is fit. a fat molecule, 55 carbon atoms, 98 hydrogen atoms, and 6 oxygen atoms. Like that's a huge molecule. But
That's pretty big.
you know,
Yeah.
it's like it, it there's no like visual conception of how that works with like modern atomic theory, but like just having a cube, it just you just putting all these blocks together and there's like 6 sides to connect to. I mean, it's just like I don't know, it's super
I mean,
logical.
we,
And of
we
course, you know, it's my granddad, I'm going to advocate for him, but
of course, you know. No, and I'm just thinking like cubes. It seems to be like the second most prevalent shape that we're working with. Like it's not even pyramids, it's cubes. Like if it's basically if it's not a circle, it's a cube or can be folded into a cube. You know, like we all know, you know, the black cube, the Kaaba, um, you know, cubicles
the
for
cross,
the cross, which folds into a cube. You know, the my apartment where I'm living now, it's basically a cube or a fucking cube shaped, at least. Um, so it also seems like a very natural form, and you know, a cube if you sand down the edges, sand down the points, it becomes a circle, it becomes a ball. So
yes. And he has circles inside the squares of the face of a cube. So they are rotating in
okay.
circles along the edges of a
Oh man,
cube.
that
So that's part of his model.
then you're coming close to the like the very well known alchemy symbol, the circle in the cube in the triangle. Oh
Yeah,
man,
he
so
even the
hmm,
protons are also um rotating. So they're like doing a dance. Um
makes sense that they
let me see
would.
if I can find a good so this AI is cool because you can have it make uh infographics.
The there is actually an early atomic model developed by Gilbert and Lewis in 1902, which positions electrons at the 8 corners of a cube to explain valency, which eventually was superseded by quantum mechanical models. So, cube atoms 1902, that's around the same time. So it's not a new idea. It was superseded by quantum mechanical models. So your granddad like actually picked up on something that did exist, but just wasn't well known, or it wasn't as well known, I
Something.
guess.
Yeah, I mean his equations are uniquely his own. Here's like a little diagram kind of thing. So you'll see in the
Oh
cube
yeah.
you have rotating particles on the face. And then here's temporal relativity, which is basically times an interval, a
Mm-hmm.
calculatable interval, which gives you hard numbers. Whereas if time is a line or a vector or a basically we view it as a continuous force with no like interval, then it makes uh anyway, it complicates things. And then and all he has like certain angular velocities that are related to all the particles are related to with certain angles. Like there'll always be like a proton and an electron will always be at 45-degree angles from each other along their trajectories. Um, yeah, this thing makes some kind of some cool
Yeah.
infographics
No,
sometimes.
that's fascinating. It's fascinating, absolutely fascinating stuff. I I'm really
Yeah.
trying my
Uh,
best to understand it, but it's so Yeah, I mean
Yeah,
like
so the
this. We all know this. We know these shapes, or at least my audience. Um, we've all seen this before.
yeah, so this was
Uh,
generated from his math. So that image, and
that's
his methodology.
that's the Metatron.
Ah,
That looks like the cube of
what
Metatron.
tetrahedron or whatever, that four-dimensional shape. What's it? The tetrahedron or something.
Yeah, no, yeah, like Metatron's cube. Let me.
Put
This
it
is a
on
good
your
vector.
screen. I want to check it out.
Yeah, yeah,
I
yeah.
honestly haven't done any outside research on any of this at all. I just simply am only like been studying his work and that's it. So like a lot of people, when you mentioned like, oh, there's, another cubic model or something like that, I haven't looked into any of that because I want to be able to understand it so I can explain it in a podcast like this, or at least practice and try to
Here,
get the
this is
message across.
this is Metatron's cube.
See, I wonder what that would look like unfolded. See, that's obviously like something that's like folded and overlaid, multiple things overlaid on each other. Whereas how he
Yeah.
did it is he would map
So
out each time interval and then you get the full picture once everything's like fully
I mean,
rotated and
it's also
overlaid.
reminiscent. It's a similar ish shape. The golden Merkaba, of course, the tetrahedral. That's this. It's also
Yeah.
very
Okay, let's compare
reminiscent
that.
of.
Okay, this is the classic Bohr model, the solar system, and this is his. Basically, his name was Philip. Um,
Mhm.
Granddad Phil. We call him Granddad because he's from Texas. And I can finish the rest of this in a Texan accent if you'd like, fair to middling.
Sure, why not? Go
And
for it.
then we got Field's theory, the cubic model, and then you see the particles moving along at certain angular velocities. So he calculated the electron velocity, um, which assumes the ground state energy is entirely kinetic energy, and then determined reduced electron orbit, uses the Bohr radius as a baseline for the electron's path, and then equates centrifugal forces, calculate the proton orbit radius by balancing the centrifugal force against the electromagnetic acceleration terms. And then a force modification for stability uses electromagnetic forces and EM forces to ensure both electron and protons orbits remain stable. And that was the spinning of the particles themselves, to create the final balance to the forces. But I think what about a it's tetrahedron, right? You've heard of that? Is it tetrahedron?
Yeah,
Tetra.
that is the Merkaba.
Yes.
That is a tetrahedron. Yeah, and I think
Four
this is
triangular faces, six straight edges, and
this is a
triangular pyramid. No, it's
pretty
no
good
quad.
vector.
I think it's the cubic one. 4D
Like
shape.
this, I think this
What's it
is
called?
the best representation that I can find, or the most clear one at least. Like it immediately reminded me of.
Tesseract. Tesseract. That's
Yeah,
what it
yeah,
is.
yeah. The Tesseract,
Yeah,
yeah.
tesseract. Yes.
I mean, this very much reminds me of of what you showed me. I mean, probably this even more
Yeah,
because
that's
it's a little more
wild.
clear.
And what's that called
This is
again?
Metatron's cube,
Metatron's cube.
and
Let me put that in my search history.
and Metatron
Back
is
to it. Oh
basically
yeah.
it's an angel. It's the one I believe directly underneath God. I'm not that good with my Christian
Yeah,
stuff,
it
of
says it's
course.
a complex sacred geometric pattern derived from the fruit of life as a map to the universe to contain all geometric building blocks of physical reality, including the five Platonic solids. So
Yeah.
it has, yeah, it has the tetrahedron, the Merkaba, the icosahedron, the cube,
Yeah.
octahedron, and the dodecahedron. So
I
it has
mean,
all of
he
those in
is
one.
Metatron is of
Mm,
course one of the archangels.
mm.
Um let's see if I can find a better description of him. I mean, yeah, of course, predominantly found in the Kabbalistic texts. He is
Yeah, that's
the
fascinating.
prince. He's the prince or angel of the presence. Um, or he is variously identified as the prince of the presence, as Michael the archangel, or as Enoch after his bodily ascent into heaven. He is commonly described as a celestial scribe, recording the sins and merits of man, as a guardian of heavenly secrets, as God's mediator with man, as the lesser Yahweh, as the archetype of man, and as one whose name is like that of his master. So he is, you know, quite important. I'd say he's quite a big deal. So that is, I mean, yeah, what a surprise! Quantum mechanics and mysticism weaving into each other. That's never happened before. Well, that's man, that's amazing. You gotta share those images with me. By the way, I wanna put them up in want to put them up in post so that the audience can like really see as well.
Yeah, for sure.
I'm gonna have to edit the shit out of this one just because I find it so incredibly fascinating. No, but just
Yeah,
because I
that
find it so incredibly
that's what
fascinating,
I've
and
been trying to tell you.
yeah, well, man, you're here.
Just kidding.
You're here now, right? We're doing this.
We are finally made it work in my schedule too. So our paths converge this Sunday morning. Yes. Um,
And he found all of this just because he said like, no, this is like whatever
he did this
science is saying.
by himself, quietly, never talked about it with anybody. I would ask my aunts or my dad, like, you know, and they would just remember him sitting in his chair, just staring off.
Wow.
Yeah. um, and I now it's like I didn't really know. I didn't even know he was a mechanical engineer. I didn't know anything about him. He died when I was 1.5. I never really asked questions. Like I mean, it was like my other grandparents were alive all the way till I was like an adult. So
Mm.
um, and so I was my grandma was awesome and very sharp and everything like that. But and this is on
I mean,
my and also I in my um you know learning about Bach Saga and ancient history and everything like that really kind of rekindled this um interest in my grandparents or my parents and my grandparents and where I come from and
your lineage. Yeah.
like my lineage and stuff like that. And this granddad is my dad's dad. So this is my far my you know, this is
Oh,
like the
that's down
line. This is the line
the
that I want
paternal
to know
line.
the most about. And so this is the
Yeah, the
line I wanted to
paternal
know the
line. Yeah, that
most
makes
about.
sense.
Yeah, because I know a lot about my mom's my mom's side because my mom has five sisters and so like
Phew.
they all are into this kind of thing into genealogy, well, one in particular. And so she finds the records in Europe and everything where everyone came from, like ship records and everything like this. But my dad's side is my is Wilson. I don't know who Will is. I want to find out who Will is. Who's I'm the son of Will along the line somewhere, and I don't know how far back that goes.
Yeah.
But and so that it's kind of it's really cool to find, it's not every day you find in your bedside drawer a new atomic theory, that
Not.
only
I
you
mean,
know about.
I thought that was a pretty regular thing. Doesn't that happen to everyone? Jesus.
Yeah, I wasn't ready for this rabbit hole when it really blew my mind trying to it took a few months to really grasp that this was even one project, because at first seeing 400 pages of math, it doesn't I didn't realize how connected the beginning 10 pages were to 300 pages in, that they're totally linked into one big proof, if I'm willing to say proof.
Sure. Yeah.
But I have reached out to physics departments. And one of the top physics department in the whole country is just a few hours from where I live. Cal State, uh,
Okay.
Cal State, whatever. And I did reach out to them and spoke to someone, but and in my conversation with the physics department, um they're basically, everyone in colleges are already in their own big projects, so no one would have time to really dive into
Yeah.
this. That's in school right now, or professors in school, they already are working on different things. But also, whenever they do have an idea, or physics has a new idea that they want to test out and stuff like that, they go to engineers to have them build something to see if it works.
Of
And
course
I
they
was
do.
like, my granddad skipped that process and just built it himself.
I
And
mean,
um
he
and
was the engineer.
he was the engineer. And I ever like once I was down this rabbit hole, like I think Lex Friedman had this like top physics professor on, and so I like, or like Eric Weinstein went on Joe Rogan's podcast and they're talking about this
Hmm.
kind of stuff, and I'm like screaming to myself, listening to these podcasts. I'm like, like, you need to hear this kind of thing. You need to take a look at this, because you guys are way off out in the universe somewhere that, like, has no tether to reality.
Yeah.
And whereas this, like, even if he's wrong, you can still, like, it still has like it still has logic to it.
Yeah.
Like that. um yeah. And so
But
I think
I
me
don't think
reaching
he's
out to
wrong
physicists is not
though.
the right.
I don't think he's wrong.
Me neither.
I think he was onto
Don't make me
something.
play devil's advocate. Yeah.
Oh no, dude. No, never. Um, no,
I'm
I
gonna
mean,
have to agree
hey,
with you.
for, well, yeah, it's your grandfather. Of course, you're gonna agree with me. Come on, man. Jesus. It's like, I'm presenting all this evidence and his years of work, but it's not true. Yeah, right. Come on. Um, no, but man, I hope that by coming on the show today, we can kind of get the ball rolling for you. And yo, what's up, C?
I'm back. As I said,
Welcome.
I'd try and sneak on as we're
Thank
balking
you.
around here. I didn't catch anything. I don't think live or recording.
Well, to link something. Oh, go ahead and mute your mic or speaker or something. There you go. Perfect. Um, to what mostly with Bach Saga, if we're gonna mention anything about it, is more in the linguistics, and I just find the word for time, the word for time, teed or tea or tick, like an antique or antiquity, it's a commonly used is tick for time, or teed with like a D at the end. Um, but and that's what he introduced, was a time tick, a tick, 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 like a frame rate to the universe, and it's in the linguistics also, for you know that time is a word for time is tick. This is also crazy, but yeah. Let me do a quick summary. Okay, the biggest things were redefining Planck's constant as an action. And he also had a neutrons within the atom were acting as shields to maintain stability within an atom. And he also changed the concept of the speed of light, rather than being this hard number, that it's actually just the maximum distance an electron can travel across a time interval. So every tick is an electron basically jumps from one location to the next location in a determined pathway in uh, uh, in relation to the angle of the proton. And that these gears, if you imagine every particle within an atom is a gear, that along each tick, these gears move and creates a geometric synchronization. Yeah, that word. And that all of these forces combined create a zero sum. All these forces, the ones going this way, create a zero sum stability. So all those forces added, subtracted, multiplied against each other equals zero, creating a stable cubic atom with particles moving along in synchronicity along certain paths on the faces of a cube. Boom. That's it in as much of a nutshell as I can do. And that E does not equal mc squared. E equals 0. And so the whole universe becomes balanced, no singularities, no three-body problems. Everything is in perfect balance and harmony. At the atomic level, thus it's also as above, so below. Or as so below is above, or whatever.
Yeah, it's same principle.
Yeah.
So, Z, what do you think? What's your retort?
It sounded like you're talking about quantum mechanics.
No, it was not Box Saga at all.
Yeah, I well, there was a little bit of root language you mentioned for time, so I figured there was some point you were making about time in the Box Saga, but
it was because Zeroleth entered stage right. So I brought up a little linguistic connection to button it all up.
okay, all right, yeah, that sounds that sounds good. I find things very like I thought I recalled at some point somebody had said that they had changed the speed of light. Like there was some scientific discovery that changed the speed of light, which then reminded me of a Futurama joke, I think that Professor Farnsworth says or something. It says like, yeah, no, it's impossible for any craft to actually exceed the speed of light. So we increased the speed of light instead, or something like that. Right. They made it sound absurd, but then it turned out to be true because of some new calculation. That's all I can remember. That's all I can contribute, because I thought it was Box Saga-ing into the conversation.
Yeah, and a few the other questions I have that I can't um that I knew maybe a month ago but kind of forgot is how space works along these time intervals because he basically along these time intervals instead of time being a vector where the electron is spinning like this, it's jumping like a tick. And I believe his calculations show that space actually folds and then comes back out. So it's not actually traveling. It's um, that space is curved, has a curvature to it, which allows particles to jump along minimum time intervals or something like that, which is
But
also kind of a fascinating concept of being able to travel a certain distance or go faster than what we call the speed of light.
but
Which he
space has a curvature by mass being in space. It is curving it. The mass is curving it. I mean, that's the classic model that we've all seen of the grid and like Earth moving along it, and by that creating a curve of some kind. And the folding and unfolding, that is what most people propose as a popular solution, if you will, for time travel. It's not like going from point B to point A, but space time folding in on itself. The popular like unfolding a paper and pushing
Yeah,
pen
like
through both
they've
halves.
overdone that, right? It's just
That's
like,
how
here's
time travel supposedly works.
yeah. Yeah, I wonder, I wish I can ask him questions, like how he would view stuff like that. What about time moving, if you force the movement of a particle, does that force time intervals to move as well? Or like how does that all work together? And there's a lot of I just have more questions, you know,
Yeah.
with the more I understand it, the more questions I have. I would love to like still pick his brain, but that's all I have are his numbers.
Z, you were gonna do a demonstration of some kind.
I was saying, like,
Who,
it
me?
sounds like you guys, they've been talking about in the quantum. I was just going to say, like, it sounds like they're just talking about the principle they've always been talking about like, just like, here's like linear time or whatever, and then you fold space, and then you can puncture a hole, and then you hop from that side to that side without moving, and that's like portal wormhole technology. And Wrinkle in Time, the fantasy novel or sci-fantasy novel or whatever, that was predicated on that premise, which is why it's called A Wrinkle in Time, because those wrinkles in times are the folds that they then stab with the device that creates the portal, so you can hop over from here to there. And that's how you travel without moving, which is also, I think, kind of the same thing they're doing in Dune with psychedelics.
So, just a little update. He viewed the movement not, particles do not follow a complex curved space-time path, but travel in circular orbits located on the faces of cubes. And he assumes a 45-degree system alignment between the particles and the cubic grid to calculate stable ground states. So it's a discrete motion rather than a dynamic curving medium. And particles jump from one coordinate to another at minimum time intervals, which he treats as the clock speed of the universe. And instead of space bending to influence movement, the universal tick dictates exactly where a particle will land on a 3D grid based on its velocity. And so he models the signal or field between particles as having a linear velocity gradient that eventually reaches the speed of light further emphasizing a classical mechanical view of motion across distance. So basically exactly what we experience in the real world is he's still applying it at the atomic scale, that there's no woo-woo probability, all this, stuff that we have to like try to comprehend rather than what we already experienced. And he's basically applying what we already experienced. It's oh gravity. We didn't talk about gravity. This is an ether. That's one we didn't discuss, but I don't know if we still have time to, or whatever, if you are interested.
I got plenty of time.
Okay. So he would base under his model, so we don't really know, no one really, we view gravity as a pull. So we have, in standard, whatever they tell us, that gravity is based on mass, and the planet has a certain mass, so it has a gravitational pull. Whereas, his model opens up the gravity as the opposite of that, a push, where gravity would be something that, I guess you would have to introduce ether to the idea. Actually, this maybe isn't exactly in his model, whereas gravity is something that you can measure, even though you don't know what it is. And so he more used gravity as a center of gravity, so to create balance. But the idea of gravity being a pull, rather than a push. This is where the singularities happen, of like a black hole is infinitely dense, or so dense that the gravity is so strong that particles can't escape, and that's why it's black and absorbs light frequencies and everything like that. And as distances in density approach zero, forces become infinitely strong, and then the math falls apart and becomes incalculatable, and then they call that a mathematical singularity. And then they tell the laymen's like us that a black hole is, at the edge of a black hole is where the singularity happens. With him, you would basically have an ether that is pushing into space and space-time. And the more space, the less space available, like as density increases, the harder it tries to push in, kind of like pushing a basketball in the water. The pressure of the water is really trying to get inside the ball, but can't. And so it makes a stronger push. The more space that's available inside the ball. But then you take a bowling ball or something more dense, then the water isn't trying to push as hard into the center of that ball, and something like that. It'd be something akin to that. And so it would give, so let me read this so I can explain it better. He would, a central pillar of his theory is that a signal between particles does not move at a constant speed instantaneously, but particles move at a gradient, a velocity gradient. And so that implies that space has a specific mechanical response time, and that the signal isn't traveling through an empty void, but is a mechanical process that's derived from the velocity of something moving through space. I don't know if that all made sense. That space is like a flexible, curving fabric, and that's what they view space as now. But his model treats space as a rigid, flat grid, like a 3D grid, and so it's yeah. So the ether would be basically the force of gravity pushing in everything, and everyone's frozen and silent. So there we go. Yeah. So space is a precision timed mechanical apparatus,
I
and
like that
Z's
theory. I'm not sure.
puff puff but not passing. Yeah, I hear you.
But Sarah, see, you were talking. Don't let me interrupt you.
Yeah. I was coming back to my seat and I heard my name real quick, and so I was double checking what was said. I had to hop upstairs for a moment. Yeah. Because we're basically talking about the nature of time. And for me, the simple place I start is that time is the measurement of change. Change occurs and it is to be measured, right? And so to me, when I hear everything that's being discussed, I'm hearing like understanding that we're trying to find something that is an absolute universal constant to be the standard measurement of time, right? And so you're doing something on this quantum level with the measurement of light, and trying to find where you have the consistent baseline of an even rate of change, right? It's kind of like trying to catch the rhythm of the song. And so you're finding that all these physics are acting upon particles and energies consistently over different things, and so the struggle to find the right place, to make the right measurement, to get you to the true exacting of a second or something like that, is the struggle of the modern day, like, physicist and astrophysicist, if you will. That's
So
a
my
that's a
my granddad granddad calculated it to be 0.587 times 10 to the negative 15th seconds is the smallest possible division of time.
okay.
Yeah,
Small,
yeah.
smallest, smallest possible. Yeah, so that's probably under all manners, and that's determined by how fast the thing that you're measuring is, and it's like basically saying you found the fastest thing that can be measured. Is that effectively how it works? Does that fit within what I just said? Is basically what I'm saying.
Um, well, basically so in my granddad's notebooks, completely solved using his equations all of the exact calculations to create a stable hydrogen atom using specific numbers, and found all of these um like the distance or amount of revolutions an electron makes along every second type of thing. And he would use remainder equations to calculate different physical locations of particles within the 3D structure of his model.
Oh, yes. Very cool. Very cool. Good. I just learned that about you today. Didn't know that about that was your dad and whatnot. Cool.
Yeah,
Yeah,
so it
so
was my
my
granddad's notebooks, but we went over it instead of talking about Box Saga. So maybe you can catch it on the tail end once it's released. Yeah, yeah, my dad's dad. Um,
This is all great stuff, and so basically with the gravity thing, he says that it's pushing, not pulling.
So no, that's more me saying that.
Yeah.
Basically,
Mm.
his equations would explain gravity as a byproduct of um all the energies within an atom achieving balance. And so when they're
Because
balanced, the
I was
frequencies they're
thinking.
getting off, yeah,
No, sorry. I was thinking about it because like one of the like a popular experience to say that like centrifugal force and like we were earlier like talking about the ball spinning above our head and whatever. A very popular mechanic or popular thing to show gravity is like the bucket with water. Like if you turn slowly, like the water falls out, but if you like swing it real fast, it's because of the centrifugal force that the water stays in it. And I was just
that's perfect
thinking,
explanation for how he viewed gravity.
yeah, and I was just thinking, like, it's not even in that experiment, it's not as much like pulling into it as it's just being pushed by the centrifugal force. It's not pulling, it's pushing.
Yeah, something like that. He would it's almost like what you were saying with the bucket of water is a great analogy because you can spin a bucket of water and that water stays in the bucket at the top here. And you freeze frame, that water is stuck at the top of the bucket opposing gravity, essentially, or the force we call gravity.
Yeah.
He's saying that you are making a perfectly balanced system, that you're rotating, that water is moving in motion and has a certain velocity and everything, and you make a perfectly balanced system. And gravity is basically the result or a byproduct of the stability of the system. And
Yeah.
he's just saying that his system at the atomic level is what the whole system is in the universe. And so by the universe being balanced, gravity is a byproduct of all these forces that are perfectly
Oh,
balanced.
okay. Oh, like that. Right on. Oh, that
Yeah.
makes, yeah, okay. Well, if you explain it like that and use the bucket analogy, we'll call it. Um, the new theory dropped, the bucket theory. Um, you heard it here first. New quantum theory, the bucket theory. Hey, credit
Yeah,
goes to.
so yeah, one of the forces that I haven't really mentioned this whole time is his magnetic forces. And so that's he ran, there's obviously you have like centrifugal forces, there's electromagnetic forces. And so some of his equations are complex I guess he coined them like electrodynamic forces, but it's like gravity is basically an electrodynamic extension of magnetic interactions between the magnetic fields. And he basically assumes that neutrons shield the electric charges. So to create the balance. So gravity might be viewed as a long range magnetic attraction of co-revolving particles that are neutralized or not neutralized at the atomic level. It's once we started going into all the forces, because I'm like relearning, like the his stuff's very complex, obviously,
Oh yeah.
but yeah, it's basically I guess that's the best way to explain it is that it's like a mechanical byproduct. of
Hmm.
all of these different forces balancing each other out. So you have electric forces, you have magnetic forces, you have centrifugal forces, you have, the uh anyway, and all these forces interacting with each other create for an atom to achieve stability, or for the universe to achieve stability, all these forces, when you add all of them up in all the different directions and all the forces, they equal zero. And that I always think about zero. Like zero is nothing. Nothing is nothing, right? It's like doesn't exist. But he was able to, you can't divide by zero. You can't, what, like, um anyway, what's that one guy's name that is like that the black actor who's like now a physicist and
Oh,
very controversial, like
Terrence
Terrence.
Howard. Yeah.
Yeah. Yeah, and like I think he was actually onto something, because like
Oh God.
zero doesn't exist, but like that he's basically saying we're all our numbers are off by one. Like if I were to take an object and you multiply it one time, in math it's one again. But if I were to multiply it zero times, I'm still left by one with one. And if I were to
Yeah.
multiply
So
this object by two, I would have three, kind of thing. But if I had
yeah,
two
you
objects and I multiply it by
you'd have
one, it
the
would be four.
two
Like,
you'd have the two
you know,
copies and the original. Yeah.
yeah,
Zero in mathematical language is a placeholder as a cycle count. It's there for a cycle count, right? Everything, there's only 9 numbers. There's only 9 of everything. You go back in time, whether your culture had a conceptualization of mathematical zero or not, it definitely didn't have more than 9 single digits. Everywhere in the world, I can't find a culture that did not work off of the single digit 9-point numbering system, right? You know what? Why couldn't there be a single digit
or
going all
12.
to 28 just randomly, right? So there is no 28. There's a new name for something that means 28 instances of one, right?
Uh,
As opposed to
Dustin, we're
9,
talking.
like 9 instances of one. But then for some
Yeah.
strange reason, if you have a 10th instant of one, it doesn't exist. It becomes the first of a new cycle. So you're
Yeah.
actually just back to one with a place point saying you've gone through a cycle of 9 prior. And if it's
Yeah.
the other way around, it's 0, 1, meaning you've never gone through one cycle before. This is step 1 of the first cycle. And
So
then every time you've exceeded 9, you've crossed the threshold in which that 0 now represents your portal or your egg or your yoni or whatever the heck your symbolic allegory for it actually is, right? So yeah, it doesn't exist as a number, but it does exist meaning something in mathematical language. Because if you also look at a scale graph, right? As a musician, of course, I want to think in terms of intervals, and then this is that thing's broken. Most of my pens here are broken, so you're like, and here's, all right, there we go. That's 0, and then that's 1. Right. And so, if you've got your graph here, there's 0, and then you've got -1 and +1, right? So there's an implied distance between +1 and -1, right? Which is just your difference across the threshold. Like, what's the difference between 8 and 12, right? Because whether 0 exists or not, you still go 8, 9, 10, which implies 1 and 0, 11, 12. 8, 9, 10, 11, 12. So to jump those 4 numbers, you count 5 numbers. You count the one that doesn't exist because it counts as, because you're counting 1 twice when you think about it. Because why do you have 10 and then 11? Why does it go 1, 0 to 1, 1? right? So that makes 10, in a sense, not exist because it's just the cycle counter of the first cycle. Then 20 is the second cycle, so on and so forth. See how
yeah.
that.
And also negative numbers don't exist. How many negative apples am I holding?
Right. Well, negative numbers, like, once again, I could just simply make that. I could go with 9.
Whatever you say is correct.
Right. Well, you can go to 9. You can go to 9, which is 10 minus 1, to 11, which is 10 plus 1. And then you're still working with 0 in that respect, right? Because you're just using the cycle count. Because, the point of -1 is it's a mathematical concept of how much value you are away from nothing. How hard you have to work before nothing actually becomes something, right? Like, you're in the red, you're in debt, you're working off the debt, you're not making money, you're paying off debt. Oh, wow, you made $1,000. Yeah, but I'm $1 million in debt. So actually, I haven't. I've made negative $999,000 or whatever.
Yeah,
right?
negative numbers only exist with money. But there is no such thing.
Well, it exists in anywhere where you are making up for loss. It's conceptual. It's conceptual, but it's real that when I have negative money in the bank account, that if I make money, they take that money because that's money owed. Because I don't have negative money, I owe that much money before the law of Gebo is honored, and I can balance out my budget. Right?
Yeah, it's like
And
the amount you need till you come to 0, and then from there.
It's not a fictional, fraudulent fantasy until we get into usury and absurd interest rates. Other than that, it's all fair.
Yeah, well, I find it interesting that so we have an apple, right? And then a bug eats the apple, and then a chicken eats that bug, and that chicken lays an egg, and then I scramble that egg, I eat that egg, and then it becomes part of my body. And so are all the particles? I don't actually have a negative apple. The apple is still there. All the molecules and particles and everything of that original thing is still there. Now it's in me, and everything still exists. So there is no negative. It's just restructured and determined to be something else. And it just, like, if we view time intervals as one big giant book, we're only observing that book at a certain page, but the beginning chapters are still there, and the end chapters are still to come. And I don't know, but that also goes back to the free will argument. Where does that apple becomes conscious?
It's
and has free will because it's me now.
Right? The breakdown process is what makes it fascinating. This gets into a kind of a more primordial context of the word quantum, which comes from, I believe, Latin. Quant, which is to counting, right? And so if I were to run back, let me find something I don't mind tearing to shit. Yeah. So, it's just like, here, I got one piece of paper in my hand. No, I don't. No, I got two pieces. No, I don't. No, I don't. I got 4 pieces of paper. My number, I'm not gaining a damn thing except for numbers of counted things, because I could tear this to atoms. I could tear it to particles. Right? And then each one of those now has new numeric qualities, because numbers is just language for counting, right? So quantum mania is driving ourselves nuts, breaking everything down into atomized things and moments, right?
And quantum, of course, also being related to quantity.
Right, quantity, right, exactly. So you eat one apple to get the thousands and thousands of particles, of substantive things that make up the anatomy of that apple.
So
that
the
goes into
words,
your body, and then your body kind of sorts that all out,
the word
right?
quantum, funnily enough, it does indeed come directly from Latin, was first introduced actually by Max Planck, on the notion of minimum amount of a quantity which can exist.
Yes, exactly. Which is why we get to atom, and we call it an atom because it is indivisible, unless you are a nuclear superpower. Then the atom is divisible.
Yeah. Okay.
Right.
Yeah.
If nukes are real.
Assuming they are.
Assuming that they are. Even though we haven't done a nuclear test in anywhere in the world in like 20 years or something.
That's something for another time,
Yes.
perhaps.
We have to
Fascinating
worry that
theory.
the Iranians are going to successfully split an atom,
Okay.
and with their successful materials that they get for it, and then they have to successfully test that and then replicate it as a properly engineered, targetable, useful military functional weapon. And this is what we panicked about instead of saving lives. But anyway, that's that's just to put what quantum can make you think about things like politics in perspective when they're trying to sell you a scientific principle for various reasons.
Do you know, have you guys heard how Einstein has plagiarized every single theory,
And
word for
married
word?
his cousin and worked at the at the patent office, and was was some sort of a small hat. Yeah, there's all sorts of things about Einstein.
Yeah. And
How he really
and
loved
who
his.
he plagiarized from was interesting too. He plagiarized his theory of relativity and E equals mc squared, and theory of inertia from um, Henry Poincaré, who wrote a book and said these theories before Einstein was even born. Oh.
Yeah.
And Poincaré had a complex theory of ether within his theories, which Einstein conveniently left out of his plagiarism.
Yeah. He's supposed to have plagiarized from Henry Poincaré, Hendrik Lorentz, and
Lawrence,
David.
yeah.
Yeah, and David Hilbert. Um,
It's become the foregone conclusion that everybody who was ever a name in a thing that shaped innovation in America that you've ever heard of was a plant that was like given the material by someone else.
yeah.
Nikola Tesla,
M-
all
Madame
all
Curie,
the stuff you love
Mercury.
Nikola Tesla for was based on things that were given to him by JP Morgan, because that's the only reason why he could never replicate them when JP Morgan pulled out of his life, is because they weren't his to begin with.
I'll put
Interesting.
in the studio chat. It's an archived link to the
Thomas Edison, we all understand, was kind of just a businessman in the technology field.
yeah.
Elon Musk is doing the exact same thing. If you listen to my interview with Tom Althouse, you would hear a few of the deep dark secrets of Elon Musk and his finagling into the system through through Hollywood, as well as selling the Musk brand through Hollywood, since
Yeah.
Iron Man 2, and all those movies, they get into that, right? And the Marvel movies were a big part of pushing new quantum mythology, which was meant to make up everything. And it had been literally what like every Hollywood movie has uh, been about in recent in like the recent decade.
So for you guys in the studio chat, I put the archived link to the book Einstein, the Incorrigible Plagiarist, which is where most of these claims are made, written by Christopher John Bjerknes.
Oh, he's the best. Christopher John Bjerknes.
Mm-hmm.
He's wow. He is incredible. And yeah, I recommend him a lot. Yeah,
I'll
I
send
can't
you the link in
recommend him
private
enough.
too.
Yeah, he's the one who blew open all of this stuff. He's been talking about this, little hat J situation for like decades. And earliest internet times, he was on writing about all this kind of stuff, all that kind of stuff, and just he has I think his book on Einstein alone is like over 1,000 pages of just oh, he's great.
Yeah, I found an archived link for it, and it has 200. Well, the archive link is 206 pages, and for anyone
I'm pretty
interested.
sure all I'm pretty sure almost everyone who talks about Jewish mysticism and everything like that and all that are basically plagiarizing from Christopher John Bjerknes. He is like the guy who has like come to understand and lay out everything with all the evidence and um all the texts and um, oral traditions and Jewish mysticism and everything like that, and all the key players. And he has, he knows all of their stuff and has been laying it out for decades and massively underrated. And a lot of people steal from him that are like on the scene now that don't fully understand everything he's talked about. So it comes out like just kind of nonsense
Mm-hmm.
ultimately, where you're like, well, there's something there, but like,
Yeah.
it's just crazy conspiracy stuff. But
Because of Einstein, most of most of the physics that gets people excited about anything, such as talking about the quantum or whatever, like we've scientific materialism, because once we reach the age of energy, and we did the whole dismissal of the energetic medium that we called the ether up until the 19th century and earliest 20th century. Probably this combined with a primal fear of industrialization because of the propaganda against uh, against the Nazis and the Wunderweapons, right? Because like thinking about the Wonder weapons, thinking about technology used for that kind of stuff. We went into this other crude route while having all of this speculative like physics, um, basically going and running with the assumption, which is still in the realm of hypothesis, because there is no real testing for the theory of relativity, right? They don't really have a test for it. It kind of has remained a hypothesis that is such a comfortable answer to them, as they were, because they switched everything to math. Science, we don't do science anymore. We we play with the numbers with the science that we already have. We're just trying to recalculate the wheel. That's all the F that we've been doing with quantum, with going into quantum, with going into the theory of relativity, and leaving it in this place. And so that's why Hollywood picked it up, because the realm of speculative fantasy is the only place where it makes sense, right? You can get an amazing movie like Everything Everywhere All at Once, and that's beautiful for the soul. It does nothing about giving me a time machine or an anti-gravity car or anything else, but it's an excellent way of telling a story. The Jewish mysticism, there's a lot of materialist and atheists of various, you know, Abrahamic mindsets that they came out of, right? There's different kinds of, some Jews are atheists and whatever, and then, you know, Christians following in suit or whatever. And if you go and you listen to like what's the mainstream, like top future promised stuff, all of it is like techno-Gnosticism. Every time I hear them talking about some new thing they've discovered that's going to allow them to do something cool, all I see is the framework of the technographic police state. And as time has gone by, that's exactly how they've tried to apply it all. And this is seen as progress by a whole lot of people because people just choose to be terrified of each other and enjoy the cage, right? And so you get this scientific cage, and then you've got an entire scientific principle separating you from a relationship with God through the quantum, right? As this replacement kind of mathematical chaos magic. Because that's
So
effectively
I
chaos magic.
yeah, and you know my granddad's theory is kind of the opposite of relativity. The theory of relativity views space as a fluid, continuous fluid that can be relative to what speed you're traveling. You know, an astronaut comes back from a month in space. He's a different age than people who have been on the planet the whole time, kind of thing. Like you go
Yeah.
faster and time moves differently, and there's time dilation and everything. Whereas, like it's relative. Whereas in his theory, everything is discrete and absolute. So there's a frame rate to the universe. And um, it turns like the relationship with the universe into like a something that is logical and along these time intervals. So you know, all that stuff, and like viewing everything as probabilistic is just that's what makes every like what's one plus one? Well, depends on who's observing and when. You know, like sometimes it's two, sometimes you have you know, you have one maybe the electrons over here, maybe the electrons over here. Eh, you know, depends. The act of observing is an action and things like that to explain it. Either way, you're right, so they can't be wrong ever because everything's a possibility in their current models of how they construct everything. And you know that I don't think AI has a real future because of this, because they're wrong at the basic level. Like you can like if you go to a chatbot, it's basically it's a probability of how it's going to frame the answer or what answer it's going to give because it's using all this aggregate data, compiling it all together, and then spitting out what's the most likely probabilistic word that's going to come after this word when I'm creating sentences and overarching ideas and stuff like that when you ask AI a question. But I
Yeah.
think that's going to devolve into um, when you got infinite possibilities, then it's just going to devolve into nonsense, and that's the ultimate conclusion of this math is it devolves into nonsense. And like what new technology do we really have? Like we have screens, I guess that's kind of cool. Cars are the same, everything's exactly the same as it was 100 years ago. There's been no real innovation, just improving upon something that kind of, you guys ever heard of MacGyver? It's
Yeah.
like an old TV show. So
The guy.
um MacGyver.
Oh, MacGyver.
Yeah,
Right. Yeah, of
yeah,
course.
MacGyver. Yeah, so you know, it's like I have, you know, 1 foot of scotch tape, a piece of paper, and you know, and two rocks. Like get me out of this prison, you know, something like that.
Yeah.
That's kind of how they are doing everything in the modern world, like using old shit, trying to make it work in a different way. Whereas this a theory or atomic, even if it's I mean, look what they've done with a theory that is most likely wrong in the first place. They MacGyvered together the modern world we have today. You can do incredible stuff with it still being wrong, you know? Um, but even the way our wires and conduct, like the circuitry within all of our electronics, assumes that they're going to lose energy. They have to wrap wires to lose to not lose as much energy as they can, because they don't know the location of particles when they're constructing microelectronics. So with a theory of, exactly where every particle is, you can build a perfectly balanced system, build a perfect um like material that contains all of the energy, that you don't have any energy loss. Um you can build infinite energy machines with a perfectly stable system with no energy loss. That's how they improve things, make things more efficient. What about perfect efficiency? You can't improve better than perfect efficiency with no energy loss. Anyway, I mean, I think if it can't be something that can't be sustained, won't sustain. So eventually it's going to fall apart. You can't progress forever. That's why the whole idea of progression, you can't progress forever. If something we learned in Box Saga is that things kind of stayed the same forever until they changed. and
Right.
then
Yeah.
and then it's just
So,
been kind of like,
did a thing, right? Everything kind of stayed the same.
yeah. There is a way to build these systems or models. Like even in Box Saga, it's like there's a way to make a strong, beautiful, healthy uh offspring, right?
Right.
Kind of thing. And we don't do that anymore. Now we have a lot of wacky humans out there in the world today.
Yeah.
You know, we got a hundred
It's like
thousand of every kind of person out there.
I
And
think
no.
yeah, I think with the demonization of our sulfur wheel, aka the swastika, as the Box Saga talks about, every year the Hyperborean family would make a decision and spin the wheel. And if it was clockwise, make more life. If it was anti-clockwise, it was learn more knowledge, right? So we've been kind of going sideways with it, where we've been not making more life and not making more knowledge at the same time. So we've completely broken that wheel, and we're completely out of sync in the societal order, right? And this is why we've been declining into the idiocracy uh, trope, where you get really into increasing the population, which involves not a lot of time for personal development. And then a schmuck like me spends a lot of time on personal development, and now my social skills are off, and I get in trouble just asking a lady if I can hold her on the dance floor because I missed a social cue, and now I'm a horrible person and I can't go back. Right? I'm like, what the fuck did I do? Am I that fucking retarded? Right? And so, like, that's an effect on me because I've been living on, produce more knowledge in my internal. I've been an anti-clockwise for quite a while now because I've been trying to build up to somebody who feels like the clockwise motion of making more life would make sense. If only the Hyperboreans were here to tell me which way to turn the wheel, right? So,
Well,
so I'm just
more in the Box
see
Saga models,
how
more of
we
like,
lost that tradition entirely and can't freaking straighten it out.
what makes a society um work really well is because we have enough people, everyone can specialize in something, right? Some people make shoes, some people are storytellers, And some people are just children makers. They're not good at other stuff, but they make good, strong sons and beautiful daughters, that kind of thing.
Sure.
And some people are just the narrators, and and so we have information systems, we have children making systems, and as long as those two things are working with special with good, everyone's living according to their title, then things can kind of flow. And you have, if you look at the swiveling stick, then if you look at it from above, it's spinning one way, and if you look at it from below, it's spinning the other way, kind of thing. So, we don't have to be good at everything. We can just be good at a few things that we're good at, and can expect, because what are they? A jack of all trades
Master of
is a
none.
master at none.
I was just thinking that. Yeah.
Yeah. So don't be so hard on yourself. Find a good nar woman who can appreciate the narration.
It's not you, it's everyone else.
Not all women were fit to become mothers either,
Yet some are.
Yeah.
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 I've got first-hand experience with that. Yeah. But guys, I'm gonna have to wrap this up.
Yes.
It's
you guys watching the game today?
What game?
The World Cup game. I think it's on in a few minutes.
Who's playing?
Not watching soccer?
I lost
football
interest after Norway was screwed. So
me too, dude. I reset my TV, so I can't watch it anymore. But
like what? No more Holland? No, I'm sorry. I can't get enough of them.
That game was so rigged. Oh my god. Oh, I mean, they made one huge mistake, Norway, but the game. You see the ball hit the wire above the field? That was insane. They didn't stop it.
There was an interesting Trump made an interesting comment, feeling that he saw a suspicious play during the Cup. It wasn't a serious allegation. He was just saying what is that? That seems kind of a strange move. And the way he described it, so okay, Don, now do all the playoffs and the Super Bowl. Because what he said, I've seen that done in NFL. Right, I've noticed it back when I pseudo paid attention.
Well, they tell you it is sports entertainment.
Sure. I mean, hey,
give them cake.
Just like the WWE. They're not.
And what gets the most views?
They're not pro wrestlers. They're
on
sports entertainers.
Yeah.
The algorithms are trying to trigger everybody, and that's just what became everything. And then now with betting and everything, it's just sports entertainment. It's just a show, just like this.
Bread and circuses.
We're just putting on a show. Yeah,
as old as time.
But are not entertained?
But that, which is also not even accurate, because those guys were fat. Like the gladiators, they were fat.
They probably needed to be to heal from wounds, huh?
Well, yeah, just superficial cuts, and if you have a big ass fucking belly, you're gonna cut into fat and not into muscle or the primary organs. And it's funny, vegans and vegetarians will bring up gladiators to prove that their diet works, because they were high level athletes, but they were fat as fuck. And had a diet mostly based of, was it legumes and beans and just
so wait a minute,
calorie
the
dense
gladiators
foods.
Well, we won't talk about the Box Saga explanation for the word gladiator. Gladiator.
maybe some other time. Sorry, Z, you were saying?
No, I was saying like, wait, you're saying that most gladiators were like fat.
Yeah.
Oh, okay. That's in the records. That's in the Roman records. Wow.
Yes, there have even been complaints about it from like spectators. Like those guys are fucking fat.
Right. I mean, like typically they want, like they show depictions of it. Like they want to zoom in on a gladiator's story, and so if it's his story, you don't want him having to be up against like lame. Like you're not going to feel like there's a threat or whatever. I mean, I'm going to say like I don't think that the fat is necessarily a bonus. I mean, you're easier to hit. Once you've cut through the skin, I doubt any fat holding is going to really your organs.
No, but you know, and that's
you're going to bleed. You're going to lose blood.
It was like, and
so
that's also another misconception. They were not fights to the death, because you're going to run out of gladiators after the first fucking event. Superficial cuts, and having a lot of subcutaneous fat protects all your major organs. So with superficial cuts, it's mostly skin and fats that you're cutting through, which is easier to heal from.
I've never heard that before. That's super cool. Yeah, it says Roman gladiators were not lean, shredded athletes, often depicted in modern Hollywood. Instead, they are more comparable to modern strongmen or heavyweight fighters, heavily muscled but intentionally carrying a thick layer of subcutaneous fat. Wow, that's cool.
Okay.
Good.
I mean, I just thought that they had like just tons of. I just thought they had tons of people from a sustained population and a sustained slave trade as an empire, right?
I mean, yeah, that too. But like, but just as modern martial arts, you have the top stars, of course, and then you have like, everyone else. You have, the Rico Verhoeven, let's say, 12 years reigning heavyweight champion. And you're going to have to protect him because he is literally the moneymaker. I mean, if anything, Spartacus, epic fucking show, by the way. Seriously, you need to rewatch it for a third time. They got that right.
Did the guy die of cancer or something? They stopped making it?
Yeah, unfortunately.
I remember because I was watching it when it was coming out, and I was like, where's the next season? And then it never
yeah, well, there is a second season, but whole different actor, unfortunately.
You're talking about the Spartacus that was on, what was it, Stars? Encore? In America?
Something like that.
Yeah, something like that, I believe.
Right.
Great fucking show.
That was,
but they got that part right. You have your top stars who make you a lot of money and make you a lot of money elsewhere as well, because, I mean, come on, like fucking Gladiator Sweat. Like Gladiator Sweat was like sold as an aphrodisiac, for example. Like now we have Belle Delphine's bathwater. Back then they had Gladiator Sweat.
I see. Okay. All right. So people had superficial cuts and things.
Mostly superficial because it was sports entertainment.
So I'm assuming there might have been a minimal amount of to the death that perhaps happened, but it wasn't like the standard of every match.
No, definitely not. And I mean, I think the movie Gladiator got that right as well. It was a lot of, replays and, reenactments of certain things. And you always have the people who die, but those are like the low tier people, indeed the slaves who were just like, here's a helmet and here's a sword. Go. Cannon fodder, basically.
Yeah. And then they sucked so bad that they accidentally let the other guy get them killed instead of playing dead would be the idea.
Yeah,
right?
or just, that was just some slave and like he was fucking worthless anyway. He didn't do well in fucking training, so who the fuck cares?
Okay,
he was losing me money, not making me money. Yeah,
okay. I can see how that that works. That definitely would be something I'd imagine would be a political. It's just like, why do we let them die at all in the games, right? So there's somebody out there who's just like, no, that slave has dignity.
No, but I mean, Spartacus got that right as well. Like, you have certain like almost mythical gladiators, like the high level gladiators, the top of the top, the elite 1% athletes, because they were still considered athletes.
Yeah.
And
yeah,
you
they
don't want
had elite care. They had regular massages by slaves, utilized ancient forms of hydrotherapy and baths, and access to top-tier medical staff to patch up their training and arena wounds.
So basically what we do with, martial artists or just any top-level athlete, that's still what we do today.
Yeah. See, I would have had assumed they just would have a separate kind of like the Olympics, right? I figured the Romans had like more of an equivalency to the Olympics, but which I think they still did. But so they would have had that kind of athleticism plus this.
Yeah.
Okay. Well, that makes sense.
They trained with progressive overload, which is how I trained when I was working out really hard.
I mean, that's
the idea of just adding
most basic,
a little bit at a time.
That's the most basic form of training. Like that is how you get strong, how you get big and strong. Anyway, guys, I've been trying to wrap this up for like plug your shit, Dustin. You first. You are the main guest, of course.
I just wanted to share my granddad's work that I found in my drawer. That's been sitting in my family storage for 40 years. I don't know what to do with it. I don't know what to do next. Am I sitting on $1 billion? I don't know.
We'll let the audience decide. So to everyone watching, to everyone listening, share us your ideas of this and what should we do with it, if we should do
and I'm not
anything
suicidal.
with it at all.
I'm not suicidal. I'm not meeting anyone at some diner or anything to discuss it.
Or some back alley. Yeah.
Yeah, I'm you know what? I just but
Dustin did not kill
very
himself.
Interesting stuff. Thank you. Yeah.
Absolutely.
Thanks for having me. Let me get the words out and trying to describe with words, nothing but numbers and math calculations, and try to turn it into some kind of story. So
it's all absolutely fascinating stuff. And dude, thank you so much for sharing and making an effort of trying to put it into words, because it is rather difficult. Z, for the people who may not know you just yet, and for everyone who is a regular viewer or listener,
just stumbled upon Stein's podcast, I'm Zeralath Eternal. You would know me from every weekend, usually on Sundays now. You would see me, or it was a Saturday show before that, doing the Tarot Rune readings. But Zeralath Eternal on YouTube, where you can catch me throwing up content here and there. A lot of drive streams, kind of stream of consciousness thing, and then I got like little prepared projects. Often like a reading club format is easy and fun, and the shit that I add in commentary to what's being read is where it's at, right? And so you can enjoy me going through the Book of Abramelin the Mage right now, which I've done, which I'm maybe about halfway through. It's not a long book at all. I'll try to bang one of those out tonight. I got Zeralath Shreds. You can keep an eye on that, because once in a blue moon, I'll record a scratch track and throw it out there to be like, here I am holding on to music, even though I've got writer's block. And that's what Zeralath Shreds is for.
All right.
Let's go.
Yeah, the wife is also calling soon, so that's why I'm.
Well, thanks for having me again, and I can send you materials and graphics and stuff to kind of
Yeah,
include within
please do, because
the
I'm
show.
gonna have. I'm definitely gonna have to include some of the graphics in post production.
I got lots.
Because
I got
it
slides and graphics. So
send me whatever you feel is relevant, and definitely some of the things that we talked about, and I'll make it pretty.
all
So
right.
yeah, thank you everyone for watching. Thank you everyone for listening. Man, and as I said, let us know what should we do with it. What do you think of it? Because all these theories are absolutely fascinating and based on stuff that already exists, lines up with quantum mechanics as we understand it. So yeah, give us a shout in the comments, or let us know on our socials, especially instagram.com/greyhoundpagans. Make sure to like, share, and subscribe to the channel for more stuff like this. Support us via channel membership or on patreon.com/greyhoundpagans. Big thank you to the people who are already supporting us. I should do those every stream or every podcast at least. That is Tanya Kamasele, I believe, if I'm pronouncing that correctly, on the Freeman tier on YouTube. Joshua Matter on the Freeman tier on YouTube. Flower Forest for the Great Horn Book Club. Make sure to subscribe to that as well. It's on the Patreon. And of course, like us on Patreon on the Warrior Aristocrat tier. Thank you so much for supporting the channel. If you want to support us as well, please, channel memberships, Patreon is the best option. Or if it's just single donations, piece of merch, go to our website, www.greyhoundpagans.com. Everything can be found on there. Check out the book saga stuff that I did with Dustin. Join me and Zaralath every Sunday for live rune and tarot readings. And yeah, I guess with all of that said, have a good morning, good evening, good night, whatever it may be to you. And until the next time on the Greyhorn Pagans podcast, see ya.
Peace.
This was yet another amazing episode of the Greyhorn Pagans podcast. We thank you all for watching. We thank you all for listening. Remember to like, share, subscribe, and hit that notification bell so you will be notified whenever we upload something new. Support us on Patreon for early access and for everything else that we do with the tribe, for everything else that we do with the podcast. Find us on www.greyhoundpagans.com. For now, we thank you, and until next time.